Okay, so this tutorial is going to pick up from where we left off last week. Last week we looked at Gecko as a way to do environmental analysis using Ecotect as a backend. And what we get out of Ecotect, the most we can get is basically colored meshes. So far, any analysis we've done, we've used mesh colors to output that analysis. And that's pretty good for visualization within Grasshopper. You can also bake that mesh and it'll maintain its colors when it bakes into Rhino, so you'll be able to visualize in your viewport. The problem is that once you render it, those colors won't show up. And that's because those colors are being applied at the vertex level in the mesh, and it's not being applied as a material. So there's two ways that color works within Rhino. There's the object color, which you're kind of used to. That's what shows up when you go into shaded mode. So here, I'm in shaded mode. I can see the colors. So if we go back to this component, remember we ended up with this mesh color. Now if we bake this, and I'll hide all my grasshopper geometry, you can see that the mesh is inside of Rhino. You can see the colors, right? Because we're in shaded mode. All these colors are just represented as an object color. The other kind of color that's in Rhino is the material color. And this is a completely different property, and it completely relates to what happens during render time. If you hit render, the colors actually won't show up. So here I'm rendering, everything is white. Because even though the mesh has color properties in Rhino, it doesn't have any material. So if we click on one of these meshes and we go to the material assignment, see it's assigned by layer, and the layer that we're on doesn't have any material assignments, so it's never going to render those colors. And Grasshopper doesn't have a built-in tool for baking surfaces with material properties, because material is something that's kind of separate from the geometry. But as with a lot of things that are not built into the base Grasshopper, we can have access to all these things through custom scripting. So I'm going to introduce you to very basic scripting, only just to accomplish this specific task, but hopefully you'll see how scripting works in general. It's actually very simple. You just have to learn the syntax. So there's not much you have to do, but you have to know the right thing to do. So in this case, I'll show you the right lines of code to write, but to actually do it from scratch, you'll have to learn a little bit of the backend. But I'll give you some resources for where to find information about different syntax and commands you can use. To show you scripting, I'm going to actually use Python script to accomplish that. So in the default Grasshopper, you have two options for scripting. If you go to math under script, by default, you'll get a C# and VB script, and those have always built into Grasshopper because they relate to the languages that the program itself is written in. Okay, so Grasshopper is written in C# and then also implements VB. But in the last few years, Python has become like a really important scripting language, mostly based around its ease of use. So it's actually a very easy programming language to learn. And because of this, it's become the main language that's being incorporated into a lot of these software. So starting with Rhino 5, Python was incorporated natively within Rhino. And it's also been incorporated with other tools like Maya. With Rhino 5, it's incorporated within the basic software, but not within Grasshopper yet by default. So to have access to Python, you basically have to install it just like any other plugin. So if you go to Foods for Rhino, under here, under most downloaded, you see that Grasshopper Python is number 2. So just a very quick overview. The way these scripting nodes work is they're laid out very similar to any other node in Grasshopper. If you click on one of these script nodes, and here we'll use Python, it'll give you this node, and just like every other operation in Grasshopper has inputs and outputs, okay? The difference is that by default, this node is an empty shell. It doesn't have anything in it. If you hover over it, it says no script to execute. So if you double click on it, it'll launch this other window, and this will give you access to this Python scripting interface from Rhino 5. And here's where you'll type your code. It also has execution kind of feedback window where it'll tell you the status of your code as it's running. And by default, whatever shows up here will also be sent to this output. And then you can specify your own input and output parameters for use in your code. So anything passed into your node along these inputs you can use within the code, and then you can output specific things to the outputs that you specify. So we're gonna write some code in a little bit, but first we need to set up our geometry for what we want to do. We know we want to bake these surfaces. We can't do that within Grasshopper, but we can prepare all the geometry to do that before we do the code. So what I want to do with this code is basically take all of these faces as surfaces, and I want to bake them into Rhino and automatically assign a material to each one and set the material's color to the color of these meshes. Okay, so most of that can be done in Grasshopper, except for the part about baking and creating materials. So that's all we're going to do in the Python node. So before we do that, we have to prepare the geometry. Right now we have meshes, and I want to bake them as actual surfaces. So we're going to do something that we did in the very first week. We're going to convert all these meshes into 4-point surfaces. Okay, so to do that, basically we need to deconstruct the meshes. So we'll plug the meshes into the deconstruct mesh. This will give us the face geometry. Then we need to deconstruct the faces. So this deconstruct face will give us the indices of the vertices of each face, and then we can use those to reconstruct the surfaces. So again, we need an item component, a list item component, to actually start to pull those vertices from our list. So we'll create one of those for each vertex out of the 4. Okay, so we'll hook up a list item to each of those deconstruct face vertice lists, and then we can create a surface 4-point surface and plug all of those vertices into our 4-point surface. Okay, and now what we have is, I'll delete this Rhino geometry that I baked. So now we have all of those meshes back as surfaces, and now they're all on different branches of the tree, but there's 840 surfaces coming from 840 meshes. Okay, so once we have these surfaces, basically we have all the inputs we need into our Python node to start to bake this geometry with material properties. We have 840 surfaces we want to bake, and from the ecotect analysis, we have 840 colors that we want to use for those materials. Okay, so now we can start to set up our script node. We're going to change the names of some of these inputs to make sense with what we want to do. So under X here, you can just right-click on any of these inputs and change the name. And here we'll say geo, that's going to be our geometry. We're going to plug our surfaces into that. Here we can flatten these. They're all in different branches now, but we don't really need that. We can just enter them as a straight list. Okay, the next input we need is the colors. So we're going to change the name to color. And then into that, we're going to input our RGB values coming from Ecotect. So now the colors are coming in there. And then we're going to make a third node, which is a common node to use in any script you do. We're going to call it active. And this will be a Boolean that basically triggers this to execute. So just like with Gecko or any of these more complex scripts, we don't want this to execute every time we change anything in Rhino, because some of these things take a long time. And this baking and setting materials is something that takes a long time. So by default, anytime we do a script, we're going to create this active parameter, and we're going to plug a Boolean toggle into there, start at false. Okay, and the last thing we need to do to set up our inputs is change the input type from item access to list access. And this also has to do with how the script will process our geometry. By default, it will take all of those as one object. But since we're inputting a list of surfaces and a list of colors, we just want to change these to list access. So Python will actually read those in as a list of elements. Okay, so we want to change that for the geometry, and we want to change that for the colors as well. All right, so that's our basic setup. Make sure you change these or else the script won't work. It's something that's kind of easy to forget because it's not visible. You don't see it here. Just make sure those are always set to list access.